In this video, we're going to look at integer multiplication models. So we did addition, we did subtraction, now we're going to do multiplication. And we're going to use a charged field model in this particular video. And then the next video is going to be the number line model for multiplication. So again, the plus means positive and negative means minus. I'll do the negatives in red. And when we're reading multiplication, whenever you get to this symbol right here, your multiplication symbol, you need to think of the phrase groups of. If you could translate this into a phrase, it's going to make this go much, much faster. So n groups of m. And are the groups positive? Are the groups negative? Well, I don't know, but it will work with all of these. So when I see 3 times 4, I think 3 groups of 4. And do you see how everything's positive? So I'm going to draw 3 groups of 4 positives. So there's one group of 4, a second group of 4, and the third group of 4. So there we go. There's 3 groups of 4 positives. And to find out the answer, you just add up how many you have. And there's 12, and they're positive. So the answer would be 12. And again, I know you guys know that 3 times 4 is 12. I'm not trying to insult you with that. The beauty of this model is it helps you see what the sign is on your answer. So it's 12 and everything's positive. The next one would be 2 groups of negative 3. So I have to draw 2 groups of negative 3. So there's one group. There's the other group. I did 2 groups of negative 3. And if you look here, what do we have? In total, we have negative 6. So you can see there, when you multiply a positive times a negative, you get a negative. Over here, we had a positive times a positive, and it was positive. So again, it's helping you see the sign. So what happens when the negative comes first? Well, if we have negative 4 times 2, that would mean remove 4 groups of 2. So this negative at the front would mean remove. Well, how do I remove 4 groups of 2 when I have nothing in my circle? How do I take away or remove what I don't have? Well, I guess I'm going to have to add in some 0 pairs. So I'm going to add in some 0 pairs. How many? Probably about 8. But I only know that because I happen to know what 4 times 2 is. So groups of 2. 4 groups of 2. There's a 0 pair. There's some more 0 pairs. I just have to put in enough 0 pairs that I can do the problem. And if you have too many, it's okay because they'll cancel out, right? Negatives and positives cancel out. So there, I put in a bunch of 0 pairs, right? So add 0 pairs. Just you throw in a whole bunch of them, okay? I want to remove 4 groups of 2, and that 2 is positive. So I want to remove 4 groups of 2. So there's 1, there's 2, there's 3, I'll say removed, right? Remove those 4 groups of 2. And if you take all those pluses and you pull them out, what's left behind? 1, 2, 3, 4, 5, 6, 7, 8 negatives are left behind. I don't know that I'm really a huge fan of this. I'm going to be real honest. What I would probably do in this case is I would use the commutative property and call it 2 times negative 4 and then work it like we did this one up here where we had 2 groups of negative 3. I would say 2 groups of negative 4. I would use the commutative property. But I'm going to model it in the notes the way that it's stated. But like in reality, that's probably what I would do. Because this 0 pair stuff is a little weird, I will admit. The commutative property won't help you here, though. That's the problem. So this is negative 3 times negative 4. So remove, that's what this first negative means, remove 3 groups of negative 4. And again, I don't have any 0 pairs, so I'm going to have to put in a bunch of 0 pairs. 12 of them. And we're talking groups of 4, so I'm going to add my 0 pairs in groups of 4. This is the most tedious part. Okay, so I added in a whole bunch of 0 pairs. And then I have to remove 3 groups of -4. Well, here's a group of -4. Here's a group of -4. There's a group of -4. Those are removed. If I remove those, what am I looking at? I have a bunch of pluses left. In fact, I have 12 of them. And so again, the idea here is to show why the answer turns out to be positive. When you multiply 2 negatives, you actually get a positive. So I think it works if you have positive numbers or if you have one number that's negative. It's a little bit of a stretch when you have 2 numbers that are negative. But again, we're just giving you options so that you can say you've seen all these different ways of working the problems.